Hi guys, today we're going to talk about solving quadratic equations, and we're really just going to focus on factoring and quadratic formula. Those are probably the two most likely methods that you were exposed to in Algebra 1, and a little bit of review heading into Algebra 2 wouldn't be a bad plan. Also, they're the most common forms of solving a quadratic equation. So recall that the definition of a quadratic equation in one variable is an equation that can be written in the form ax squared plus bx plus c equals 0, where a cannot be equal to 0. If a were equal to 0, that would mean you would no longer have a quadratic equation. In general, you're looking for the variable x to be raised to the second power, at least as one term in your equation. That's what really makes it quadratic. And we call this the standard form of a quadratic equation. And remember that before you solve a quadratic equation, especially by factoring, you want to combine any like terms. You want to set the equation equal to 0. So whatever, set the expression, everything else equal to 0. And then you want to try to solve by factoring. And if you can't solve by factoring, then we're also going to talk today about using the quadratic formula. There's a couple other methods you're going to learn in Algebra 2, which are efficient and helpful. You just want to have as many tricks up your sleeve as possible when you're trying to solve. Some of us kind of struggle with factoring a little bit. So when you solve a quadratic equation by factoring, you are looking to factor the expression typically that's on the left-hand side into two smaller expressions. Usually you see those written in parentheses, and you'll see what I'm talking about when we get to an example, such that if you were multiplying them together, then either one factor is equal to 0 or the other is equal to 0. And that zero product property is typically the method that you use when you're solving by factoring. Let's take a look at a few examples and you can understand what I mean. We're going to solve each of the following equations by factoring. Notice that in this first example, it's already written like a factor. So 3x minus 1 is a factor being multiplied by 4x plus 5. So like in that zero product property, it's like this is a times b equals 0. And we just want to set each factor. Recall that once you get an expression factored, notice how problem A differs from problem B and C and D. So each of these is slightly different. We'll do something a little bit different. But A is already expressed in factored form. And in general, with a lot of the other problems that we do, we're going to try to get them to be in this factored form. So right now, we just set each factor equal to 0 and solve. So we're going to set 3x minus 1 equal to 0, or 4x plus 5 equal to 0. And then we're going to add 1 and get 3x equals 1. Divide by 3 and get x equals 1/3. Or, and then we're going to solve the other one. So we're going to subtract 5 and get 4x equals negative 5. Divide both sides by 4 and get x equals negative 5/4. So we have two solutions. It is very common when you're solving a quadratic equation that you have two solutions. Sometimes it might look like there's only one, but maybe it's a double root. And you'll learn a little bit more about that in Algebra 2 as well. Let's take a look at problem B. X squared minus 5x plus 6 equals 0. Notice that it's already set equal to 0, so that's a critical first step that's already been taken care of. So we're just going to try to factor x squared minus 5x plus 6. And if you've forgotten a lot about factoring, you just need to let me know so that we can review that a little bit and talk about doing some factoring problems to help you along a little bit. But recall that you're looking for two things that you can multiply together to get x squared. So we're going to put an x first here and an x first here. And then we're looking for two numbers that are going to multiply together to give me 6. And then they have to combine to give me 5. And the way that they need to combine is they have to add, in a sense, to give me 5. So we can't use 6 and 1 because 6 minus 1 would give us 5. But we can use 3 and 2. And then I usually wait to do the signs last. Some of you do the signs first. Notice that when you're trying to consider the signs, you look at the sign of the last term. And if that's positive, then you look at the sign of the middle, and that tells you that each of those signs in parentheses should be a negative sign. So we've got x minus 3 times x minus 2. If you want to check it just to make sure, remember that we forced the x times x to give us the x squared, and we forced the 3 times 2 to give us 6. So ideally, hopefully, you only have to check the outer and the inner by foiling a little bit, so just the outer and the inner. So when we multiply x by negative 2, we get negative 2x, and we multiply negative 3 by x, we get negative 3x. And when we combine those, we do get negative 5x, which was in fact the middle term. So that's just kind of like a checks and balances a little bit that you may want to do for yourself if you haven't been factoring for a long time and you've forgotten a little bit how to do that. Then set each factor equal to 0, x minus 2 equals 0. You're going to get to the point where you probably can skip that step, x equals 3 or x equals 2. Right? Sometimes when you type your answers into that program to try to answer, you're just going to type in a box 3, 2, or you might type it from least value to greatest value. Let's move on to problem C. 50x squared minus 16x equals 0. One thing that I'm going to remind you about is that when you're solving equations by factoring, you should really always try to look and see if you can factor out a greatest common factor first. If you look at problem A, it was already factored. Problem B, there was no greatest common factor. But in this case, there is a greatest common factor. They both have a common factor of 2, and they both have a common factor of x. So we're going to take that greatest common factor out. And what do we have to multiply 2x by to get 50x squared back? That would be 25x minus, and then 2x times what would give us 16x? That would be 8. So we get 25x minus 8 equals 0. And then we still set each factor equal to 0. We can set 2x equal to 0 or 25x minus 8 equal to 0. Divide. We're just going to solve the 2x equals 0 first. Divide both sides by 2 and get x equals 0. Or, and then we're going to 25x minus 8, we're going to add 8 and then divide by 25. So we have 25x equals 8 and divide by 25, divide by 25, and we get another possible value of 8 over 25. And you're done. Again, notice 2 solutions to that one. Now we're going to try to solve D. We've got x squared minus 24 equals 10x. Notice it's not set equal to 0 yet. So first, set equal to 0, which means we're going to have to subtract the 10x. And you want to make it look like it's in standard form. So you really want to write it as x squared minus 10x minus 24 equals 0. And then again, we're going to try to factor. I call it, I think I grew up learning it as trial and error. Some people call it guess and check or whatever. I'm looking for 2 things that I can multiply together to get x squared. That's x and x. So I'm going to put that as the first value in each set of parentheses. Then I want 2 numbers that are going to multiply to give me 24, but subtract to give me 10. And I know it's got to be subtract because the last term is negative. And if the last term is negative, then I'm going to have opposite signs in here somewhere. Doesn't matter whether you put the plus first or the minus first, but they do have to be different signs if that last term, the constant term, is a negative value. So what can I multiply together to get 24 and subtract to get 10? I know you kind of have a tendency to want to think about 6 and 4, but they would have to be the same sign if it's 6 and 4, okay? So when we think about another factor pair, 24, sometimes you're used to listing factor pairs like 1 and 24, 2 and 12, 3 and 8, 4 and 6, et cetera, and you're looking for the ones that when you subtract them, it's going to give you a 10. So if I subtract these 2 values, 2 and 12, I'm going to get a 10. Notice that I want the 10 to be negative, so that means my 12 should be the one with the negative sign, and the 2 should go here. Again, if factoring is a big concern, then you're just going to want to reach out and let me know that you need a little extra assistance with factoring so that we can practice a little bit. I'm going to check the outer and the inner. This gives me negative 12x, and the inner gives me a positive 2x, which does in fact equal negative 10x. So I know that we factored it correctly, and I'm just going to erase this and get it out of the way. Get all that out of the way. And then setting each factor equal to 0, x plus 2 equals 0, or x minus 12 equals 0. So x equals negative 2 or positive 12. X equals negative 2 or positive 12. Those are the 2 solutions we get. All right, last one we're going to do by factoring. This is probably one of the most challenging problems you might face. Again, the first thing we're going to do is we need to set it equal to 0. So 12x squared plus 13x minus 14 equals 0. All right, why is this so a little more complicated? Well, first thing I notice is there is no greatest common factor, because although 12 and 14 have a common factor of 2, 13 does not. And then the next thing is that there's a coefficient in front of the quadratic term, so that 12 there in front of the x squared makes it a lot harder for me to figure out what should go in parentheses. But we're just going to use guess and check a little bit. If the guess and check doesn't work for you, then you're going to like using quadratic formula, which we're going to talk about next in just a minute. So we're going to go ahead and we're going to use this guess and check a little bit. I'm going to go ahead and put, let's see, a 6x and a 2x right there. And then I need, what can I multiply together to get 14? I'm going to try 7 and 2. Well, here's what I notice. Because there's a 2 that I put here and a 2 that I put here, there would have had to have been a greatest common factor, because there's a common factor that I could pull out of those. So clearly that's not going to work so well. Let's rearrange it a little bit. If I put the 2 over here with the 6 and the 7 here, now I can't take a common factor out of the last set of parentheses, but there's still a common factor of 2 between 6x and 2. So maybe something else is not right. I know that the only other factors of 14 are 1 and 14, so I'd still be able to take out a common factor. I'm going to leave the 2 and the 7. Why don't we change the 6x and the 2x? Let's make them 3x and 4x. 3x and 4x. Let's try that. Now notice that none of these expressions has a common factor. And let's just see what we need to do with our signs. Since the last term is negative, that means I need to have one of each. So I need to put in, let's say, a positive and a negative right here. So now I'm going to check the outer and the inner and see if I factored it correctly. I have negative 21x and I get a positive 8x. That gives me a negative 13x. Negative 13x is not really what I want. It's the right value, but it's the wrong sign. So this is not okay. So since it's the right value but the wrong sign, then it's likely that the only thing that I need to fix is the signs. So what we're going to do is now we're going to change the 7 to be negative and the 2 to be positive. Now let's check the outer and the inner one more time. We're going to get negative 21x, we're going to get a positive 8x, and that will combine to give a negative 13x, and that works. So it's a little bit easier. When the coefficient of the quadratic term is something other than 1, then some students have a hard time factoring because they're still trying to apply a similar method, and it doesn't always work out the same way. So it may be easier for some of you, if you really struggle with factoring, to use quadratic formula on a problem like this instead. Now I'm going to set each factor equal to 0, so 3x plus 2 equals 0, or 4x minus 7 equals 0. 3x equals negative 2, and then divide by 3, and x equals negative 2/3. And add 7 to get 4x equals 7, divide by 4 to get x equals 7/4. So if I write that solution, I would get x equals negative 2/3, comma 7/4. And that's it. All right. Let's talk a little bit about solving using quadratic formula. There are some students that are a lot more comfortable with solving using quadratic formula. Some students believe that the quadratic formula just is kind of made up from thin air. Who makes this stuff up? This isn't a made-up formula. It is derived by applying another method to the standard form equation, standard form quadratic equation. And so that's called completing the square. It's something you're going to learn in Algebra 2. And you can ask a teacher to show you how the quadratic formula is derived if you wish, or if you want to talk about it, then we can discuss it a little bit when you're interested in just having a conversation about where that comes from. You are more formally acquainted with just memorizing the formula and applying that. And I know that a lot of us, some of you have probably had a teacher that kind of does it in a little sing-song voice, like opposite b, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. So if you had, I know some of the other teachers that I work with have definitely done it like that, to the tune of Where's Thumbkin or Farachaka. If you like that, fine. If you can memorize it, fine. Great, either way. So we're going to solve this equation using the quadratic formula. It is important to always set it equal to 0 first. That's going to be common, and I'm not really going to do examples where you have to go through that. You should just know you want to put it in standard form first, so you want to make it look like ax squared plus bx plus c equals 0. And just to make it useful, I'm going to identify a is 3 in this case, b is 8, and c is negative 3. So quadratic formula, x equals opposite b plus or minus square root b squared minus 4ac all over 2a. So then I'm going to plug everything in. Negative, and 8 goes in place of b, plus or minus square root. I'm going to go ahead and put some of these other things all over 2, and then we're going to square 8 minus 4 times 3 times negative 3 all over 2 times 3. And here we go. We get negative 8 plus or minus the square root of 64 plus 36, 36, all over 6. So we get negative 8 plus or minus the square root of 100. So this was factorable. I know it's factorable because the square root is a perfect square. So negative 8 plus or minus 10 all over 6. And here's what's going to happen with that. If you want to use the quadratic formula on something like this, you got to make sure that if you get to this perfect square and you've simplified it all the way down to negative 8 plus or minus 10 over 6, then you need to separate it. Negative 8 plus 10 over 6 and negative 8 minus 10 over 6. So we get x equals, this is going to be 2 over 6. So x equals 1/3. And this will be negative 18 over 6, which would give us negative 3. So we have two solutions, 1/3 or negative 3. So it was actually possible to factor it. I know it's possible to factor because the square root ended up, the radicand under the radical symbol ended up being a perfect square, which means it was a factorable type of expression. We're going to try some that might not necessarily be factorable. Let's give some of these a go. We're going to solve using quadratic formula, and if there's no real number solution, we're just going to state that there's no real number solution. There's no real number solution if you end up with a negative number under the radical, because you have not yet learned the system for how to take the square root of a negative number, but you also get that in Algebra 2 a little bit. So notice that most of these equations are already in standard form. They're already set equal to 0. I'm just going to identify a equals 2, b equals 3, c equals negative 1. And I'm just going to go ahead and plug in. So x equals opposite of b plus or minus the square root, b squared, that's 3 squared, minus 4 times a, which is 2, times c, which is negative 1, all over 2 times a, which is 2. So negative 3 plus or minus the square root of 9 plus 8, all over 4. And x equals negative 3 plus or minus the square root of 17 all over 4. And that's really all you can do with that. It can't be simplified further. You cannot simplify the square root of 17. That's a prime number, and 3 and 4 do not have any factors in common, and you could leave your answer just like this. Or you could write it separately. If you're going to write it separately, it would look like negative 3 plus the square root of 17 over 4, comma, negative 3 minus the square root of 17 over 4. That's how it would look if you're going to write it separately. Okay, so for problem B, what I'm going to do is, I don't really like to deal with fractions too much, so I'm just going to multiply everything through by 4 so that it can cancel with the last term. And I'm going to end up with 4x squared plus 12x minus, and then when I distribute to the last term, it's going to cancel with the denominator, equals 0. So again, a is equal to 4, b is equal to 12, and c is equal to negative 3. Just helpful for you to identify it for yourself off on the side. So x equals opposite b, negative 12, plus or minus the square root, b squared, that's 12 squared, minus 4 times a, which is 4, times c, which is negative 3, all over 2 times a, which is 4. So x equals negative 12 plus or minus the square root of 144 plus 16 times 3, that's 48, all over 8, and x equals negative 12 plus or minus the square root of 192 all over 8. I think 192 can be simplified. So if you're not sure, then you really do want to take the time to simplify and break down that square root of 192. I'm pretty positive that 4 goes evenly into 192. That goes 4 and 3, 2, 8, 48. And this can be 16 times 3. So I would have 4 times 16 times 3 under the square root. 4, you know, is a perfect square, and that can come out as a 2. 16 is a perfect square, and 6 square root of 16 is 4, and I'd be left with 3. So this is going to end up being x equals negative 12 plus or minus 8 square root of 3 all over 8. Now, what you should notice is that the negative 12 and the 8 and the other 8 all have a factor in common. We can divide all of those by 4. So we're going to divide by 4 and get 3, and divide by 4 and get 2, and divide by 4 and get 2. And our final answer should look like x equals negative 3 plus or minus 2 square root of 3 all over 2. And you're done. Okay? Let's try again. Let's try this last one, problem C right here. Let's see if we can move this down. There we go, a little bit, get a little more space. So we're going to identify A, B, and C once more. A is equal to 2, B is equal to 3, C is equal to 5. So x equals opposite B, negative 3, plus or minus square root 3 squared minus 4 times A, which is 2, times C, which is 5, all over 2 times 2. X equals negative 3 plus or minus 9 minus, and 8 times 5 is 40 all over 4. So x equals negative 3 plus or minus square root of negative 31 all over 4. Okay, so up to this point, you have been taught that you can't take the square root of a negative number. So at this point, you're going to say no real solutions, because in Algebra 1 and geometry, we really haven't covered complex numbers. In Algebra 2, you're going to learn how to simplify that square root of negative 31, but we're not quite there yet. And if you try to do it on your calculator, your TI-30X2, it's not gonna fly. It's going to tell you that it's a non-real answer. So there you go. And that's all we've got for today on solving by factoring and using quadratic formula. That's it.